So hello everyone on a very rainy, gloomy Monday morning, and I hope everyone is well. So I'm going to pick up at slide 60 where we left off. And the big topic today, of course, is the big section on Chapter 8 called the Capital Asset Pricing Model. And this you must know, okay? This is very important, and this is the theory that ties risk and return together, but please be careful, not for diversifiable risk, but for systemic risk, like we're dealing with now, okay? All right, so this links risk and return, okay? Now this risk, total risk, is made up of two components, right? Diversifiable, as you can see here, and non-diversifiable. Now, non-diversifiable you can get rid of simply by holding a lot of stocks, right? We talked about that many times, right? So you can get rid of that. So diversifiable, you can get rid of, and that's called unsystematic or unsystemic risk. Okay, but it's an important concept and real important. So hold on. All right. So you have unsystematic, right, or diversifiable, which is right here. All right. Let me highlight that too. That's important. All right. And then we move on. And we have non-diversifiable. And non-diversifiable, another name for non-diversifiable is, I don't know why. Well, hold on. Let me hold on. Let me unhighlight that. I don't know. It's crying. All right. Let me get that done. All right. I don't know. It's going crazy here. Every once in a while it goes crazy. All right. So non-diversifiable, also known as systematic risk. Okay? And that's systematic because you can't get rid of it no matter how hard you try. And you notice all stocks these days are dealing with it, right? So that's the same term. All right? All right, so this is an important graph with regards to reducing your risk, okay? So here's the total risk. You see this bar right here? This is the total risk, okay? And this section is the non-diversifiable. This you can't get rid of. But you'll notice here, the more stocks I buy, you notice here number of securities, the more stocks I buy, this is going down. So I'm getting rid of the diversifiable risk, all right? So total risk is made up of two components, diversifiable and non-diversifiable risk, okay? And remember, for diversifiable, the more you buy, the less problem it is. All right, so the capital asset pricing model, and here's the important thing. The important thing is that it links non-diversifiable risk to expected return, okay? Now, a lot of times people use different terms for expected return. They'll call it required return, okay, and expected return. It has a lot of different names. So inside this, in the equation you're going to see in a little while, is very, very simple, all right? It's a very simple equation. So you're going to see in a little while, inside that equation is this thing called beta. Every stock has a beta. Now, what I'm going to ask you to do, if you have a chance, is just go online on Google and please type like the beta of Microsoft, the beta of Apple, and they'll all come up. Now, beta is a measure of non-diversifiable risk, and beta changes all the time because the market changes, right? So this is important. So if the market return is going to change, the question is how beta is going to tell you how much your stock or asset's going to change, okay? And the market return is the return on the market portfolio of all traded securities. Now, by definition, the market return is normally the S&P 500, okay? So the S&P 500 has a beta of 1. All right. So let me S&P 500 has a beta equal to 1. Okay. So that's important to know. All right. All right. So the beta coefficient is so you get this line called the security market line, right? And basically that will give you the beta. All right. The slope of the line we're going to look at is the beta. All right. So here's the asset return, and here's how we derive beta. So this is your asset, okay? And here is the market return. So for different companies, look, Pepsi-Cola, Bank of America, where these meet, right, is where you'll get your beta. You see over here, they have a little slope. If you remember taking algebra, slope is change in y over change in x. Well, this curve will give you the beta. This is a least squares fit for this data, okay? So the beta is the slope of these lines. One for Bank America, one for Pepsi-Cola. And as I said, you notice it keeps changing all the time, right? So it's something that varies and changes. Okay. So betas can be positive or negative. And betas, and they can be large. And a positive beta will move in the same direction as the market. Okay. And a negative beta moves in opposite directions to the market. And, you know, each of these terms goes along with one of these betas here. Okay. So this is twice as risky and twice as responsive, I guess, as the market as a whole. And this is twice as responsive in the negative direction. Okay. All right. So as I already said, the beta coefficient for the entire market is 1, the S&P 500. All right, so don't forget that. It's an important concept. So I'll put this here again. All right, so all of the betas in relation to that 1, all right? So as you can see here, the majority of beta coefficients fall between 0.5 and 2, all right? All right, so this is a great table, and this is just a general sampling. This is a sampling of beta coefficients for different stocks. So you can see GE moves pretty much with the S&P 500, and Apple is a little more aggressive. Look at Bank of America. They're a little risky, right? And Qualcomm's a little risky. It's greater than the S&P 500. So, you know, these are so any beta you can get online just by typing, you know, beta of the specific stock name, okay? All right, now, even portfolios, if you got a portfolio of a lot of stocks, even portfolios have a beta, okay? So this now slide is the portfolio beta. And depends on what you got in your portfolio. So the beta is the weight times each specific beta. So the weight of each stock in your portfolio times its specific beta. And remember, the weight is always have to add up to 1. The weight's always equal 1. Okay, so this is again how to get the beta for a portfolio. Okay? So I just want to make sure we know the difference between a single stock and a portfolio. All right, so here's a nice example, and they go through the you know, portfolio. Go over this slide, and if you have any questions, email me. So here's a typical table for two portfolios, right? V and W, And you can see he's got different proportions here of different stocks, 5 stocks in each portfolio, but in different proportions. You'll notice the proportions add up to 1, right? And he calculates the beta for each stock. So he's got the beta and he's got the proportions. And then all he's got to do is basically go back and multiply them together and add them up. And he'll get the portfolio of V&W's beta. Okay? All right, so here's the big equation you all have to know, and it's all very important. So this is the capital asset pricing model. And here's the equation. And the only thing you have to know about calculating this is you take the risk-free rate. Now that's given to you. This will give you your expected return. All right, this is the beta of the stock. This is the market return. Again, here's the risk-free rate. And that's it. That's all you have to do. Okay? So you basically pop 3 numbers in there, 1, 2, 3, and you've got your answer. All right, so that's all you have to really do. So as I said, the risk-free rate of return is derived off T-bills, okay? So that's important to know. It's the T-bill rate because there's no risk. You'll always get your money back, all right? So we'll highlight that. You can see it's a 3-month U.S. T-bill. All right, so here's the risk premium for stocks. Here is the T-bill rate, right? Treasury. Here's T-bonds. So the risk premium is going to be 1.5% for Treasury bonds and 7.6% for stocks. Okay. All right. So here's another. Here's another example where he's simply calculating the capital asset pricing model to determine the rate of return he needs. So you can see the risk-free rate is 2, the market return is 6, the beta is 1.5 as given, and the answer comes out to 8%. Okay. All right. So here's how he explains that, right? 8% required return. All right, so there's a graph associated with the, Let me go back here, sorry. So there's a graph for the capital asset pricing model, and it's called the security market line, okay? And remember, it's for non-diversifiable risk, okay? And you can read this example here. So notice here, here's your required return. Here's a beta of 1. That's your market risk premium. Everyone see that? So that return is 6% on the S&P. And for different assets now, you'll get different betas. This is called the security market line, okay? I want to make sure everyone's clear about that. That's the security market line, and where the beta intersects your required return for all right, you'll get the, you could plot this, okay? So different betas give you different required returns. Okay, so the risk-free rate comes down. There's a thing called the nominal rate. All right. Oh, I'm sorry, the risk-free rate. F is risk-free, right? And that's equal to the real rate of return plus the change in inflation. Okay. So we've got to know that. So how do you get the risk-free rate? Even though it comes from Treasury bills, this is how they get it, okay? So it's important to know that, all right? Here's a couple more examples that you can go over from your book. Okay, so now inflation is going to shift the security market line, you see, because that's going to change the risk-free rate. Look at the risk-free rate from going from here to here because of inflation. You notice how that's gone up? And so you notice the security market line has raised up, okay? So you're going to need a larger required return, okay? So I want to make sure everyone's clear about that, all right? So the inflation or the increase in the risk-free rate will increase the security market line. Okay, so if the risk-free rate stays the same, okay, but the market risk premium changes, now this ain't going to change, but the market risk premium could change too, so that'll shift this up too. See the market risk premium changing here? RM is going from 6 to 9. Everyone see that? So that'll flip the curve up even higher. All right, so that market risk premium will go up. All right, so that's about it for chapter. Please read the chapter. As again, the capital asset pricing model is the most important thing. All right, so please know that. Okay, alrighty. Stay safe, everybody. Stay dry.